Hi, good morning, everyone. I'm a data scientist, I guess, data visualization person, really. I was originally going to talk about something slightly different, but I'm going to talk about things I think you'll find interesting around narrative and data visualization and the things we do in research to try and improve the way visualization presents data. I'm a professor at Newcastle University in the far frozen north, and I'm also a research fellow at the Alan Turing Institute when it's open in London. Okay, so I'm going to try and stick to quite a short talk and do 3 quick sections. One is I'll just talk a little bit about what and why you might want to use data visualization, reflect upon that a little. I'm going to show a short film on data narrative. I'll say a bit more about that before we run that, and then I'll come back and talk about communicating data intelligibly to commanders. So we've picked up a theme in the last few years on decision making and providing uncertainty information quickly and clearly to command level. So command level is Gold Command in the police, Army, battalion commanders, and Cobra type meetings in government. So for us, what's data visualization? So it starts on the left here with some kind of data, usually hiding in the cloud, streaming to a computer system. The computer system draws a picture of the data that is presented on a screen, and at that point converts from digital electronic information to optical light wave information, passes across space to a viewer. The viewer detects it, their eyes see it, they perceive it, and the cognition system kicks in and they start to understand the data. And that generates ideas for them. And in the gap between these two things is really where we sit. What representations of data can we build that help people understand the data in a clear and efficient and quick way? And this problem for us is getting bigger and more difficult all the time. The data part on the left is getting bigger and bigger every day, whereas the human part on the right is pretty much staying the same. So we also spend quite a lot of time talking to psychologists, vision scientists about what it is what can you see and what can you think about? What are the strengths and limits of the human visual and cognition systems? So that when we draw pictures, we match them to things we know. Unlike artists, we're trying to convey the same thing to most people. So we're trying to draw pictures that will be interpreted in the same ways. Okay. Why would anyone want to use data visualization? Well, if we go back to about 1800, Johann Pestalozzi said this: visual understanding is the essential and only true means of teaching how to judge things correctly. The learning of numbers and language must be definitely subordinated. Great quote. You think, well, excellent for visualization researchers. Why should we listen to this guy from 1800? Well, it turns out he created a teaching method used in Switzerland, which taught Einstein, educated Einstein. And in Einstein's whole career, he always said he had to see ideas before he could do the maths and think about them. So visualization became very important to him in the most complex ideas in physics. In the 1970s, John Tukey said the greatest value of a picture is when it forces us to notice what we never expected to see. And if I had £1 for every data set I've drawn a picture of, and someone's going, oh, I didn't know that about my data, I wouldn't have to apply for any more research grants. Let's put it like that. So I think visualization is this tool, and it helps us, although I don't entirely like this pyramid from data to knowledge, but it helps us go more quickly through this pyramid where we go from raw data in computers to knowledge and wisdom in humans. And it gives us faster and more accurate cognition when it's working well. A couple of quick historical images. Florence Nightingale, about 165 years ago, had this great quote: visualization affects through the eyes what we fail to convey to the public through their word-proof ears. I like that. I think I'd have liked Florence Nightingale. And she famously drew this famously not entirely correct picture of deaths in the Crimean War and influenced the military's choices about what to do about that. Another group of people I like, Otto Marie Neurath and Gert Ernst, created a system called isotype or isostat in Russia, with these very iconic styled images, which led to all sorts of things, including the Geneva Convention on road traffic signs and pretty much all of today's icons and emoticons. And their quotes, "Words divide, pictures unite." Another great quote for us. Okay, so before I move on to something else, I'll show you this, I think. Let's get this working. So when we look at pictures and we look at visualizations and we process data, one of the questions we should always ask is what is it that we're really seeing? Are we seeing a signal? Or are we seeing the data? And in this case, this rotating shape you'll see is projecting very different shadows in different directions. And very often when we see data, what we see is a projection of some type of what you might call the raw or original data. It's important for us to understand when we're doing statistics on data, whether that statistics is about the shadows or about the object that they represent. In that sense, a lot of the questions about truth and trustworthiness in data require quite a lot of analysis to work out whether data really is trustworthy. Okay, so now I'll just pause this share, switch to another one. I'm going to do this, which should look like a black screen to start with. So for a number of years, I worked with cosmologists visualizing the creation of the universe from the start of time to the present day, which is a subject which endlessly fascinates people. And we did lots of 5-minute movies about that. When I moved to Newcastle, we were looking at the Urban Observatory data and how that measures Newcastle and its environment. And we wanted to try and create a similar representation that was more comprehensible, more understandable to people than the raw data and the maths, which is very much what the cosmologists are doing. The maths of cosmology is uninterpretable to anyone who's not a cosmologist. So I'll just run this about Newcastle. I normally talk over it, but you'll have to read the subtitles because me voicing over won't work so well. So I hope that worked. Let me switch back to the slides. So one of the challenges for us in this was that we have these sensors all over Newcastle. We've worked with a local council, and one of the questions they always ask is, how do we know which sensors are reliable? Because they know some of them are very expensive sensors and some of them are very cheap sensors. And this has led us into a track which has become a lot of our work in the last few years on representing uncertainty in visualizations. And I'll just go through some of the things quickly that we've done, and then I'll stop. So we've started a track on intelligible uncertainty communication for decision makers. How do you make uncertainty an everyday part of decision making, and indeed presentations to the general public, so that it's normal to understand that data is not certain, rather than it being presented as this perfect thing, which everyone likes to do. Our first project on this was, let me move this down so you can see it a bit, was shortly after the Salisbury Novichok incident, and DSTL and PhD were very interested in conveying simulation results of an outbreak of an infectious agent across the city. It happened to be Manchester they ran the simulations for. And I certainly don't have time to go through everything we did, but I can show you this. We wrote an 80-page report on uncertainty visualization, and there was about 30 of us worked on this. And on the right, although it's not interactive here, a tool I would recommend if you're not into R or Python is Power BI or Tableau, one of the desktop visualization tools, excellent for quickly visualizing things. We built a very quick interactive tool which allowed us to slice out very quickly the high impact areas of the city where the infectious agent was affecting the city with high certainty, so that both those things came across at the same time. And we built a whole series of these as prototypes, in fact, but this was one of the simplest ones. The instructions at this time were at command level. People have no interest in graphs or plots or statistics or uncertainties. And I think I would echo that even now, that in communicating out to the public or communicating to high-level decision makers, don't communicate like data scientists. Save R plots for communicating with other data scientists. Find new ways to communicate upwards and outwards. A second scenario we ran last year was with the British Army. And this was very quickly a humanitarian aid ship at a port in the Middle East dropping off supplies. And there was an intelligence that they were going to be attacked with a CBR, chemical or biological weapon. And then the plan is to, how do you inform the commander what the likely outcome of that is? And back at base in England, they would run 500 simulations of this with different outcomes. And it's the variation in the outcomes that we needed to get across. This time, we were working with a set of captains who said, well, when they're advising commanders, they thought they could explain the graphs. So if you've got someone there who can explain the plots and the uncertainties, that might help. But in many situations, you don't. But we came up with this very structured, you wouldn't believe this single page took 3 days of 10 people's work, but it did. A very structured approach, which mapped onto some things the Army already do, where you have a request box with the limitations of what you're doing, a summary with a single line summary of what the outcomes will be. So based on the modeling, leave on day 1 or day 3, day 2 is not the best choice. Then more details, then the plots, and then a numerical summary. And the captain said they have about 5 minutes to get this across. So there is some time to explain it, but not much. And it's a part of a whole series of briefings that commanders will get before they make decisions, normally, if they're not deciding about COVID lockdown. Moving on to this year, then we took that same outline we'd worked on and used it actually in June with a group of people from the Newton Institute at Cambridge and a group of about 30 mathematicians to convey to University Gold Command, the VC and the groups around them, what the impact of COVID might be on buildings, on campuses and the nearby communities. And again, that was an 80-page report we distilled into about 10 pages of visuals. I won't go into the details, but this is just one of them on the planning for what might happen in lecture theatres. Again, the assumptions, the summary, some plots about how to lay out lecture theatres, and some plots of simulation results, giving outcomes based on different levels of talking. Okay, that was a very quick whiz through some of the background to what we do. I haven't got time to show you the research, but that's okay. You can talk to me later if you're interested. But there's some directions that our research is going in. In data visualization, I think we strongly believe that design is not enough. You can't solve data visualization problems through design. We need rigorously generated scientific knowledge. And so some of that comes from existing knowledge in vision science, some of it from our own experiments. Intelligible uncertainty. If you want trustworthiness in data, we need to find ways to present it with its uncertainties so that people understand the range of confidence they can put in a piece of data. But at these critical moments, decision makers do need uncertainty. And our challenge really, and I've got a meeting in a couple of weeks about a new MSc strand on this, is how do we communicate data with truth? How do we make sure that the data we're presenting is in some way truthful? And a lot of what we just saw was talking about the processes in journalism that people use to try and do that. Okay, thank you very much for listening.